and no time. We can't use the formula, right?
Right.
So we can't say V equals D over T if we don't have this and we don't have that. So what are we going to do? What did we talk about yesterday that would let us solve if we don't have those? Subtract or add, one of the two. Okay? So when we look at this question, are they going in the same direction or in the opposite?
They're going to say they're both going to sell.
What, Brooklyn? What? Yes. All right. So if they go in the same direction, what did we say we did yesterday? What did we say we do if they go in the same direction yesterday? They add. And if they go in opposite directions, we do what? We subtract. So when you look at the question, because I said what? 10 miles per hour south and 25 miles per hour south, what do we know?
So they're on the same direction.
Are they the same or opposite?
Same.
They're the same. So we're going to add. We're going to say 10 plus 25, and we get what? 35. And how do I write the answer?
Okay.
It needs two things. It has to have a unit and a direction. Miles per hour, and I heard Chanda say it, south. Okay? Now, let's say, and you don't have to write this one too, but just to offer some contrast. All right, let's say that we have this one. All right, a plane flies 650 miles per hour west with a headwind of 100 miles per hour. All right, what's the velocity? All right, what does a headwind mean? It's coming at the plane. Okay, so I know it's a terrible picture again. But if you have a plane that's flying, stop worrying about the plane.
Is it a cloud?
Is it a truck once?
All right, so if the plane is flying at 650 miles per hour and the wind is blowing at 100 miles per hour is a headwind, are they going in the same or opposite directions? Opposite. So a headwind is blowing against whatever vehicle it is, whether it's a plane or a car. So what's it going to do to the speed? You're going to subtract because it's going to slow it down. So 650 minus 100, so you'd get 550 miles per hour, and then your direction is west.
How do you know if they're going the opposite direction?
So what now?
How do you know if they're going the same or opposite?
Because anytime it says headwind is opposite. What would I say to be the same? Tailwind. Okay? It has to be a tailwind to go the same direction.
Oh, we gotta know all this extra stuff.
It's just a tailwind and a headwind.
So headwind is opposite.
Headwind is opposite.
That's too big.
Tailwind is the same. Really? Two words like that are going to throw you off. I wouldn't have thought that, but okay. All right. We got it?
No.
Okay. Tell me when you do.
Yes.
Man, I ain't coming, y'all. Man. Last time I came out,
It's away.
Man, I about lost my voice.
It's a
For no reason.
I was trying to get it. I ain't lost.
For no reason. Okay.
Just trying to give anybody else a concussion today.
You could go. Zakaria's good player.
It's good.
All right. So our next lab that we will, what's tomorrow, Friday? We might get started on this tomorrow. And I already asked this, but is there anybody who cannot chew gum?
I'm sure sorry.
Okay. The lab is a chewing gum lab. And you know how today some of us worked and there are a few of us who just copied somebody's paper? This lab is an individual data lab, meaning everybody choose their own gum. So I know. So everybody writes down their own data. So will your calculations match your classmates' calculations? No. So you have to learn how to do this yourself so you can answer and calculate your own lab sheet. All right.
Is this gum diabetes free?
I typically don't buy diabetes-free gum. I typically buy double mint and juicy fruits. Okay, that way you've got a choice of some fruity or some minty. Now, acceleration is what the lab is on.
Is the title of the notes acceleration?
Yes. So, acceleration is defined as the rate of change in velocity.
Well, maybe you should maybe see that on space.
Okay? Which basically means how much velocity changes over time. Jeremiah, be quiet. All right? How much velocity changes over time? Now, don't write the word formula. I'm going to come back to that. Oh, if you did, it's okay.
All right.
Now, I want to talk about the three ways that an object can accelerate before I talk about the formula. Okay?
Would it going down the hill be one?
Yes. Does everybody have the definition? All right. So, what are the three ways that an object can accelerate? So, Arturo said going down a hill. So, what happens when we go down a hill?
Gravity.
What is it? Oh, put it on the back counter by the measuring tapes. Okay? So, if we go down a hill, we do what?
Gravity.
Okay, thank you, sir. Do we speed up? Slow down? What happens to us? We speed up. Okay?
How much velocity changes over?
All right. Generally speaking, we speed up or velocity increases. All right. That's one. Number two. Jeremiah, take that off for me. All right. Number two.
Oh. I thought, so why did you skip formula?
I'm coming back to it. I already said that.
Oh.
All right. What's the second thing we can do to change the velocity, which will cause us to accelerate? Shh. What else can we do?
You tell us.
That's what I'm asking y'all.
We don't know.
The third one I know we're going to struggle with.
But the second one we should know.
I think so.
It's gonna decrease.
Decrease in what?
Speed.
Okay, decrease in speed.
Okay, so slow down.
All right. So slow down. Or we can say velocity will decrease. All right. So for the last one, I'm going to give you a hint. Tell me the definition for velocity again.
Rate of change. Oh, never mind.
Not the definition for acceleration. For velocity. Speed with what? Okay. So we've already talked about change of velocity by increasing or decreasing our speed. So what is the other part of that definition that or next to direction?
Yep.
So how can I accelerate?
Change direction.
There you go.
Oh.
Okay. We can change direction.
Oh, isn't that like what ice skaters do?
Yes.
How they go like that way?
Yes. If you just skate in a circle, you're changing direction. You're accelerating. Now, before I give some examples of this, is acceleration a scalar or a vector? All right, let me ask this again.
Vector.
Tell me what a scalar is.
Just a number.
That's enough.
It's just a
A
number.
vector had
Never
direction.
mind.
All right, and a vector has direction.
So this is a vector,
So it's a vector.
period.
Okay? It has direction, so it's a vector. Now, most people don't have any trouble figuring out that when we accelerate, we generally speed up. Everybody's like, I got that. That's all that makes sense to me. But I don't get 2 and 3. All right? A lot of times when we slow down, we use a word that starts with a D. Anybody know what word I might be talking about?
That's what I'm saying.
Mm-mm. It's like accelerate, only put a D on the front of it.
Decelerate.
I
Decelerate.
ain't never heard that in my life.
All right, decelerate or deceleration. Now, a lot of physics teachers don't like the word deceleration.
So they got physics here.
We don't teach it here, no.
Oh.
All right,
So I'm about to say, it's like,
all right. They like the word negative acceleration because, as Shinovia was saying just a little bit ago, she's like, I don't like this class. It's got too much math in it. All right. So when we calculate very shortly, some of our numbers are going to be positive and some of our numbers are going to be negative. So if it's a positive number, we're going to know what about our object. It did what? It increased. It sped up. If it's negative, we're going to know what?
it slows down.
It slowed down and it had deceleration. It had negative acceleration is the way physics teachers like to say it. I'm perfectly okay with saying it decelerated because I'm not a fancy physics teacher. Okay? Now, any of y'all driven in a traffic circle?
Yeah.
It'd be a circle where people come in from usually 2 or 3, 4 directions, and you just drive in and have to yield to people. And some people say it's a roundabout. Traffic circle, roundabout. There's one at the community college. They're building one over by Egger. You've been out there at the park where Egger's being built. But it's a way. You've driven in one, Raphael? You go bathroom? Yeah. All right. Now, when you go in a traffic circle or in a roundabout, there's no stop signs. Everything's a yield. And people the idea is nobody stops. Everybody goes in at constant speed. So people go in. Do you need me to hang on to your phone? You can keep mine company over there. It doesn't look as nice as mine, but mine might be lonely. Put it up. So when you go into the traffic circle, everybody stays at constant speed. Now, if we're at constant speed, are we accelerating?
No.
I would.
You get tired.
If you're
and
at
stop.
constant speed.
Okay. If we're at constant speed, can we be accelerating? For example, in a traffic circle. Okay. So we have a little roundabout, and I can't draw this very well. My cars look terrible.
It's a nice truck.
Yep. So my little truck drives around there. And I'm supposed to draw this poor little truck upside down, so it's bad.
That's a flaw.
I know.
Looks like the pizza.
With wheels. Piece of that over.
We can look at good icon.
You know, it's like a skater. It's like a skater.
Go about.
This works a lot better with the mouse instead of my fingers.
Thank you, Robin.
I think I'll see you roll well before.
Oh, my car lost its wheels.
What are you trying to get him size 13?
Your car lost your wheels.
I know, as I just said, lost its wheels.
What was she saying about Papa?
All right. It's not pretty, but there we go. All right.
That looks good.
Now, if I was Ms. Wicker, I'd have done this ahead of time, and I'd have had pretty graphics. But I ain't too good with the graphics. All right, so I got a roundabout with some arrows here. So, I arrive in my roundabout. I'm driving in a circle. All right? I'm at constant speed. Can I be accelerating if I'm at constant speed?
No.
Yes. Brooklyn, I know you two aren't talking across my room while I'm teaching. Now, can I be at constant speed if I'm accelerating? Why?
I was guessing.
Because you turning?
What?
Because you turning.
You change the direction.
There we go. The answer is yes. Because we are changing directions. As long as you are changing directions, you're accelerating. It's like Arturo's question or example from a second ago when he was talking about ice skaters. All right? Brooklyn, that sounds and looks to me like you're still talking across the room. No, you're not. We don't need them stretched. They look plenty big enough from here.
Oh, she's
Because look
trying to
at
burn. Oh, you trying to burn.
you. I'm not. You have your mouth wide open. You're sitting back there going, look.
Can you go back? Because I didn't get that other part. I was feeling.
Oh, she's trying to burn.
I'm not. I just want you to be quiet. Focus. You're a senior. That's going to be sending me emails from Miss Floyd or Miss Katie Wood. Who's your counselor?
I'm not telling you. Keep trying to burn.
They're going to email me and say, how's Brooklyn doing in your class?
Good.
How can you be doing good if you're not even listening?
You said it's constant because it changed direction. I'm listening. Why are you recording me? Why you
Miss Watts,
No.
Y'all are the going to the bathroom group of people I've ever seen. Y'all want to tell me how many hall passes y'all get again?
3.
3. Until when? December.
I'm going to let mine run out.
Okay, after 3, you have to do what?
Lunch detention.
Lunch detention.
I love lunch detention.
You used to, Arturo. All right. So, if you're changing directions, like Arturo's example with the ice skaters, if you're skating in a circle in the rink, are you accelerating?
Yes.
Yes, because you're changing directions constantly when you're ice skating. Okay? Is everybody with me on that?
Yes.
Okay. Now, find your orange card. I want to show you the formula for acceleration because I don't like the way it's written on your sheet. Okay, so find your formula sheet. Look for it now.
Right here.
All of you.
Formula sheet.
Yes, the orange card that I gave you.
Big orange.
The big orange
Are
card.
they supposed to keep
Look,
that?
this
Oh,
one.
there.
Oh, I can't
Never
never
mind, I got
down.
you.
Now, this is one of the 2 formulas that I do not like the way they wrote on the reference table. Okay? So if you look at acceleration, everybody found it?
No.
It's not the one that's the lab that I gave back that's on cardstock because I accidentally ran it on cardstock. It's the one that's the reference table. It's the A equals. And it says VF
Minus BI
minus VI
over triangle T.
over triangle T.
That's too much.
Now,
Dang.
okay? I don't like the formula for this reason.
It's ugly.
It's not ugly. I just don't care for it because it's the same thing as writing triangle V over triangle T, and they could have written it that way just like they did velocity.
So we got to write triangle?
Nope. Don't write it on your orange card. I'm just telling you they could have. They chose not to. Now, the reason that they didn't, I have no idea. They didn't share that with me.
So it is A equals B.
If they want you to find velocity using this formula, which you will have to do, okay? You will have to use this to find velocity. How many V's are in the formula? Most people look at that and they're like, there are 2 V's. How am I supposed to find 1 V? You have to recognize that if you only want one V, you have to collapse that into how many V's? You have to remember to collapse that into one V, okay? They're the same formula, but they wrote it this way, okay? Now, what is the F and the I? VF stands for final velocity. And VI is initial velocity.
Wait, is this right down on this table?
Nope. What's on the table is all you get. Remember what I told you. If you take notes on the table, you don't get to use the table. Now, if you look in the very right-hand column, next to where it says VF, it might have it, but it might not. Nope, it just says V is velocity. It doesn't tell you the F and the I. All right, so final velocity just means last. Initial velocity means first. Okay? Now, the reason I don't like the formula is, well, you always have two velocities.
No.
No. And if you have two, you know what to do. You subtract them. If you only have one, you just plug in one. But because they gave you VF minus VI, students assume there will always be what? Two. There will not always be two. So if there's not always two, you just change this VF minus VI into a what? Just make it a V, okay? You can easily take that and change it to that. A lot of times in class, I will even change the formula and write it as A equals V over T, because if you have two times, we know we do what with it? If we have two V's, we do what with it? Subtract. We don't even need to write it this way. This is the way the state gave you the formula.
So we can write it like that.
You can write it like that every day of the week.
Oh, I'm erasing all this in there.
Okay? We're going to come back to graphs tomorrow. Okay? All right. We'll do graphs tomorrow. All right. So write that down and we're going to calculate. Because I think calculating acceleration is pretty easy. Taz, do I need yours?
What you mean?
What I mean?
I'm using a calculator right now.
Right.
Right, because I don't know how to add these.
Do I look stupid?
What?
Still have it on, don't worry.
I'm glad to hear it. All right, so when we look at the problem, you okay over there?
Right.
Sorry, I think something got it. One of those big mosquitoes. Thank you.
What's the selection for the goes from da and 6? So you put da over 6.
Big ass.
All right, the only thing that makes this weird for most people is the unit. Dick, you with me back there? Yes, no?
Maybe.
Okay. Remember, you told me when you were resting your eyes, you were still listening to me. What? All right, has everybody written the problem down and wants it?
Yes.
All right, so A equals V over T. Or we can write A equals VF minus VI over T. It does not matter which formula you use, they're one and the same. All right, how many velocities or speeds were we given?
Two. I like what?
Okay, these are what? What are those? You can call them velocities or speeds, I don't care, as long as you know they're the same. So this, being first in the problem, is the initial. This being last is the final, for those of you who want to use the formula the way it's written on the sheet. That's how it's designed to be used on the reference table. The first is VI, the second one is the final. Okay?
Is it safe to almost always assume that the bigger number subtracts, you don't have to worry about?
Except when we have positive and negative numbers, and I'll tell you how to figure that out
So this,
very shortly.
so this would be a negative or something?
This one's going to be a positive because it's speeding up. I'm going to tell you how to figure it out. Okay? So, A equals, subtract your two numbers, 80 minus 45
Oh, I thought you
over what's your time? So what's 80 minus 45? 35 over 6 is going to be not quite 6. 5.8, 5.9. Somebody divide that for me. 36 divided by 6 is 6, so it's got to be like 5.8 or 5.9. 5.8. All right, so the units. On top, we had miles per what? So miles per hour. And then on the bottom, I had what?
Second.
Nothing cancels in acceleration. Okay? No unit will cancel.
That's too much.
So wait, that says miles per hour per second?
Yep.
Okay.
Keep them all. So even if it had been meters per second, you would still keep them all. You'd have meters per second per second. All right? All the units stay when we do acceleration. All right, well, let's see if I can find one that answers Shelby's question. All right. There's a clock there.
You see that? The blur, it's a white blur, white blur.
3:21. All right. I'm gonna wind up having to keep yours.
Chicken and Tom.
We gotta write that.
Yes.
Father is in there.
You don't have to write anything. I never grade your notes. I'm merely giving you suggestions so that it helps you.
Pardon the interruption. We have a bus change for this afternoon. Bus 294 will ride bus 331. Bus 294 will ride bus 331. Have a great afternoon.
Have a great afternoon.
If you want to ride that bus,
I'll write that one.
make sure you keep track.
I'll write my answer. 331.
Now, as you're writing, can anybody tell me what's different about this question?
It's not accelerating.
It's not accelerating, it's what? All right.
Negative acceleration.
This one says deceleration. That's what's going to make this one different.
Dang.
So it's 25 minus 10.
Mm-hmm.
So this one I have the negative.
I hear music. I knew I was tripping.
I'm sure you're not. Whoever's got a plan, turn it off. All right. Now, has everyone had time to write, or do I need to wait?
I got it.
All right, we there? Now, again, it's designed on the reference table for you to use the formula VF minus VI over T. With this being the first, this will be VI, this will be V5. So when you plug into the formula, you're going to have 25, minus 75 over 0. 10, genius. over 10 seconds. So you get 25 minus 75, which is what in math class? Negative 50 over 10, which will give you negative 5. And then again, miles per hour per second. Now, let's say that I think Caleb said he didn't like that formula. He said, I don't want to use that one, Miss Wall. I want to use A equals V over T. So he doesn't have the VF and the VI. So he just looks at the numbers. And he says A equals 75 minus 25 over 10. So he just gets 5 miles per hour per second. So how is he going to know the order of the numbers? Exactly. Because the question said deceleration, he's got to know, oh, it was deceleration, so the answer has to be what kind of number? It's got to be a negative number, so all he has to do is put a negative right there, and he's good to go. So it doesn't matter which formula you pick, as long as you can read it. Does that make sense? All right, let's talk homework, and then we'll be done. I'm only giving a few problems. I'm not even going to make you do the whole sheet.
I'm not here no more.
You're not here no more.
Oh, we still
All
can
right,
see
you're a
you because you
figment of my
cannot.
imagination.
Yeah, I'm just a plain shadow.
A what?
There's 12 questions. I want you to do the odds. That means you got to do 6.
I hope that you know that.
All right? I check tomorrow. You have to have what? Work. I should see some math. Odd number.
No.
Did you really just say 1 through 6? I said odd. Somebody tell me what odd means.
Who said so? Bruh, come on. Who said?
So 1, 3, 5, 7, 9, and 11. Not 1 to 6.
Okay, before you got to like.
You're the one who said 1 to 6.
All right now.
If you have a calculator, please put it in the tub.
Wait.